in section 8.4, we're going to learn how to simplify dealing with rational expressions. And rational expressions are just anything that can be written as a fraction. I think the formula for that, the way they denote that in the book, is something like this: a function divided by another function. And what we're going to do is divide, multiply, add, subtract, but it helps if you know the basics before that. So think back to early math days. If I said to do 8 divided by 4, what you could do is break that up into its factors and then cancel those factors out. So for instance, I know 8 is the same thing as the factors 2 times 2 times 2, and 4 is just the factors of 2 times 2. And what we can do is we can take those factors and we can cancel them. Those 2's cancel, those 2's cancel, and what you're left with is just the remaining factor of 2. And we essentially did the same thing back when we did learning properties of exponents with variables. If I had, for instance, x to the 5th divided by x to the 2nd, that's the same thing as the factors multiplied together. Factors of x to the 5th are x times x times x times x times x. And then the factors of x squared is x times x. And what those do, again, just like before, they cancel. Those 2 cancel, those 2 cancel. And you're left with x times x times x, which is x to the 3rd. Okay, we learned a shortcut for that, but the properties are still the same. So what we're going to do is we're going to apply those same concepts that we already know to things that we've already got coming up. So the first example we're going to look at is taking those same ideas and applying it to this new concept. Okay, so if you notice here, we don't have things multiplied together. We've got 3 terms either being subtracted or possibly added together. Down here we've got 2 terms. There is no multiplication like we see up here in these previous 2 questions. So what we're going to do is just like we did earlier. We took 8, we made it into its factors. We're going to do the same thing with these 2 expressions here. And we learned how to factor all these back in chapters 4 and chapters 5. So this should not be that difficult to do. If you have a hard time with factoring, you need to make sure you brush up on that and make this a lot easier. So what I'm going to do is I'm going to factor the top expression first. So this is 3 terms. There's no number in front of the x squared. Factors of negative 15, that will get you negative 2 when you add them together, are negative 5 and positive 3. Again, that's something you should be able to do without too much problem. Factoring the bottom, since there's only 2 terms, and this is a perfect square, and this is a minus, you break this up as x plus 3, x minus 3, because the square root of 9 is 3. Now, if you notice, we've got 2 things being multiplied together on top, 2 things being multiplied together on the bottom, and we can now cancel the factors that they have in common. If you notice, we have an x plus 3 in common with this x plus 3. Nothing else will cancel. The x's don't cancel. They're not being multiplied to the negative 5 or the negative 3. You have to leave those as they are. So your final answer is what's remaining on top over what's remaining on the bottom. And the common mistake that people make is they want to start canceling these x's. You cannot do that. If you notice, this x is not being multiplied, it's being subtracted by the 5 and this one by the 3. We could cancel these because it was being multiplied and you were canceling out the entire set. Okay? So let's do one more example. Example 2. Or example 1, just an extra example of example 1. This is one that we probably did not do in class. This one here, same thing. We cannot cancel anything yet. You can't jump to canceling the x squared. You can't jump to canceling the x's here. You have to factor first. So what you always look for when you factor is a GCF. This one has one. This has an x squared. That has an x. So I can take out just an x, which leaves you with an x and then the plus 4. That's something, again, you should be able to do pretty comfortably after we did chapters 4 and 5. On the bottom, same thing as we did earlier. You got 3 terms. There's no number in front of the x squared. So you look to see what factors of negative 24 will get you negative 2 when you add them or subtract them together. And that's going to be negative 6 and a positive 4. And you're kind of looking for things to cancel. I mean, there are times where things will factor and nothing cancels, but more often than not, when you factor, you're going to have something in common. If you notice these x plus 4s are the same, you can cancel them. And the only thing that's left over is the x on top and the x minus 6 on the denominator. And that is your answer. And again, you cannot cancel these two x's. This x is not being multiplied to anything. If you were going to cancel the x's, you'd have to cancel everything, which you can't do because of that minus 6. All right, the two examples we just did were single fractions being simplified together. Now what we're going to have are two fractions, or potentially more, but probably just two fractions being multiplied together. But you do this the exact same way. Okay, you want to look to factor first. And what I'm going to do is I'm going to rewrite this top left. I'm just going to write it above. I don't have to rewrite the whole thing. I like to have mine in descending order of powers. So see how the 3x squared is not written first? I'm going to write it first. Negative 3x squared and then plus 3x. So I'm not going to look at that right now anymore. I'm just going to kind of scribble it out. So this is my new question. So what I'm going to do is I'm going to factor everything. I'm going to factor out a common factor between these two terms. So I'm going to take out a negative 3 and an x. If you take out a negative 3x between these two terms and you divide it, negative 3x squared divided by negative 3x is a positive x. 3x divided by negative 3x is a negative 1. That's the hardest part of this question. On the bottom left, same as earlier, 3 terms. There's no number in front of the x squared, so you're going to break up your fraction or your binomials. Factors of negative 5, that will get you a positive 4 when you add them, are a positive 5 and a negative 1. Remember, that should multiply to get you negative 5, and they do. 5 times negative 1 is negative 5. 5 minus 1 is a 4. That's an easy way to check your work. On the top right here, factors of negative 20. That will get you a 1 when you add them, are positive 5 and negative 4. And then the bottom right, this 3x, since it's just a single term, there's nothing to do with it. Just leave it alone. So what we're going to do now is start canceling. Look for things in common. They have to be on different levels of the fraction. Okay, so if you notice, this x plus 5, even though it's a part of a different fraction, it's on the denominator, that's on the numerator, they can cancel. These x minus 1s can cancel. This 3 and that 3 can cancel. This x and that x can cancel. So the only thing you have left over is a negative on top and an x minus 4 on top. There's nothing left on the bottom except, if you think about it, there's really a times 1. You can put that with anything. So it's really over 1, but we don't need to put that. So my final answer can be written as this, or you can go ahead and distribute that negative through to get negative x plus 4. All right, one more example for this video, and then I'll save the rest for another. It's the same example, just another type. This is one that we did not do in class. So if you want to pause and try this on your own and then replay it to see how you did, that's fine. I'm going to go ahead and work this out. Factors of 20 that get you a negative 9 are negative 4 and negative 5. You need to be able to do that easily. If you can't, you need to go back and practice those from chapter 4. Same thing with the bottom left. Factors of 14 that get you 9 are 7 and 2. They're both positive. Again, 7 times 2 is 14. 7 plus 2 is 9. It's really easy to check. The right fractions, same thing. Factors of 8 that get you 6 are 4 and 2. And then the bottom, factors of negative 20, that gets you a negative 1 are negative 5 and a positive 4. So the last thing to do is just to start canceling, and then whatever's left over is your answer. So x minus 5s cancel, x plus 2s cancel, and x plus 4s cancel. This time you have things left over in the top and the bottom, so your answer will include both of those. You can put the parentheses, but since there's not more than one set of binomials, you don't need them. So my answer is x minus 4 over x plus 7.